Yeah, good morning, everybody. And this is Dr. Mansour with the Professional Engineering Services and Education. Welcome, everybody. Sorry to wake you up early in the morning, but this is a price for the PE. In order to get your PE, you have to pay the price. And the price is just try to do your best and try to understand as much as you can and solve as many problems as you can. And I will keep helping you guys as much as I can. Looking to the set of problems that I received from one of you, question number one, the textbook sample problem 424 about the HSO, the horizontal site offset. Is it necessary to solve for both directions? No. One direction is going to control, which is the inside lane, and this is why the radius R of the equation that I will show it to you in just a minute. It is the radius measured to the center line of the inside lane. So the center line, the R, is the center line of the inside lane. And you may say, why did you solve also for the outside lane? Okay, this was a previous PE problem, was given by the PE, by the NCEES, sorry, the people who administer the exam, and they release the problems from one time to time. So normally I buy these books and see what type of problem they ask in the past after they release it. And they try to use it to just to give you more insight about the topic itself. You are completely right, and we're going to go to the problem, and you'll find the problem, it does have two things. If this is the center line, okay, and I believe it has both directions, and it has a grade also. The grade is very, very important, which is G. Okay, so let me bring the problem, at least you can save time. And if you don't have the book, as I always say that, I will be glad to send you the problem that we are talking about, just in case if you don't have the book. And this is a problem 4-24. This is a horizontal design. Chapter 5 is a horizontal design. Let's go to problem 4-24. Okay, and this is 424. Forgive me, just which is this problem here. Okay, so as you can see here, I color it for you when I was talking about this problem. This is the center of the curve. Okay, the center or the radius point, as we call it sometimes. And okay, this is the R. And if the R is not given to the center line of the inside lane, you have to adjust that. And this is what happened here. He give you the radius, okay, to the edge of pavement. So in this case, the R has to be adjusted, okay? We need to be aware of that, okay? So this is, there are two directions, as you can see, the yellow and the orange one. And there is a grade here. The grade is given, okay, the G is given as 5% in this direction. So, and they ask you what is the distance X. We have a fixed object here. Let me zoom in a little bit. The fixed object, okay, that will block the sight of the driver, okay. So we have two lanes. This direction, this is the inside lane, and this is the outside lane. I checked both of them, okay, and obviously the inside will control the design, obviously, okay. Because it's going to be, okay, the most critical one. The other thing that I needed to be aware of this problem, that the object, which is a car in this case, is not at the center line of the inside lane. So I give you the distances, the distance A, okay, and B and C. Okay, so you have to be, okay, it's 4 feet, is not 6 feet, is not in the center of the lane. So the NCEES, not the NCEES, sorry, the AASHTO book. And let me get the picture as given in the AASHTO book, which is this picture, which also I color it. Here it is. This is the figure 3-13. Figure 3-13. This is in my book, but if you need the original, I believe I have it here somewhere. Hopefully I can find the book in 22 seconds. Figure, this is chapter chapter 6. No, I need to chapter 3. So chapter 3, and this is a figure 3 dash, okay, 13 on page 3 dash 115. Okay, I think I am very close. Here it is. I'm lucky that I opened it. On I was able. This is the original document. Always I need you to be aware, and I need always to look to the original document, and every table that you are using, don't look to my book. You are very welcome to look to my book, but I need you to look to the original. And if you believe there is any discrepancy or typo, like my friend is telling me there is one table we are going to go over at super elevation, he doesn't believe that the table, maybe his table has an old one, maybe, I don't know. I will verify that. So this is the origin. This is the figure 3-13 of the geometric design of highways and streets, which is, they call it the green book. The green book. And I was talking to a friend of mine yesterday, as I told you, that he took the exam, but he didn't make it. He didn't pass. And the mistake I did, the mistake that he did from my point of view, which I told him that all of us who are busy, all of us, including me, and you are busy. But in order to pass this exam, I always stress the number of hours. I said that you need to sit and study minimum 500 hours. And you may upset with me because I'm suggesting too many hours. This is my opinion. You are very welcome to do whatever you would like to do, but I encourage you to try to secure at least 500 hours by sitting and understanding and solving problems. This is okay. These 500 hours you cannot finish them in one month. Okay, the month, okay, it doesn't have this number of hours. So my friend, what he did, he was so busy, like me, okay, or like you, or like all of us, and he decided to take 1 month off before the exam, or maybe 3 weeks, if I can remember exactly. And he said that I'm going to study this in 3 weeks. I told him this is a big mistake, because our brain or our computer has a limited capacity. If you try to squeeze as much information and as much knowledge in a very short time, we will not absorb it that. But if we absorb this over 6 months, for example, 6 months, and consistently, okay, you need to put a schedule. 3 months, maybe you can do it 3 months. I have no problem. 4 months. This is your decision based on your schedule and family responsibility. So try to absorb as much as you can and solve problems as many as you can, but don't try to crush everything or crunch everything or squeeze everything in a very short duration, because I believe we will have a problem with the absorption rate is very okay, because if you study, okay, the absorption rate, it increase, and after that it will be leveled like that after your brain is say that I cannot take it anymore. So if we spread this absorption over 3, 4, 6 months, I believe the absorption rate will be much better, okay, and the knowledge will be really okay, well stored in your brain. So I told him you cannot do it, and he didn't listen, and unfortunately he didn't make it, and he started to study again and is going to take the exam in August. I told him you have to push it okay, far, to absorb more. So try to do your best. I know you are in a rush to get your BE as soon as possible, but instead of going to the exam with 100% readiness, no, I prefer if you can go to the exam with 150 or 200% readiness, especially according to him. And this is just yesterday I was talking to him. He told me, because I just remember the story yesterday, okay, sorry, as I would discuss it yesterday. They are giving you the PDF, and this according to him, and this according to my understanding. They give you the PDF in chapters. Is not the entire book. For example, the geometric design of highways and the street, as you know, it has 10 chapters. 10 chapters. According to him, again, I'm repeating this statement, or according to my understanding, that they give you the PDF of these 10 chapters separately, and you have to go and search for each chapter separately. I told him they didn't give you the entire book. He told me no, and this is what I was told yesterday. So if you don't know the chapter, okay, first of all, you need to know which reference, geometric design of highways and streets. And after that, I need to go to chapter 3. And I need to go specifically to figure 13-3 if I'm going to use this figure, because immediately under this figure there is the equation, which is the HSO, the horizontal side offset, is equal R, and this R, they say the radius of the curve. This is misleading. Let me avoid the word misleading. Inaccurate description. Inaccurate description, because if you look to this R here, according to this drawing, this is the center line of the highway. Okay, and let me color the other lane, the orange one. Let me put it that way. This is the other direction. I wish that if they said that R is the radius of the center line of the inside lane, or to the center line of the inside lane, it will be more accurate, because during the exam sometimes we take the definitions and we take the equations, because under the pressure of the time you don't have time to think. But probably the radius of the curve, okay, the radius of the curve to the center line of the inside lane. It should be written like this in order to ensure, and from the drawing you can see. So this is R to the center line of the facility. This is the center line of the highway according to this drawing here. But if you look to the drawing they provided, this is their drawing. This is the original document, by the way. It's not my, okay. You will find that the R is defined up to the center line of the inside lane, and the center line of the inside lane, we are assuming this lane is 12 feet, so it is 6 feet here and 6 feet here. But the line of sight, or the eye driver, the problem that I have in my book, I said is not exactly at the center. No, it is offset a little bit here. It is 4 feet from the center line. So you have to consider that as far as calculating, okay, the HSO, the horizontal side offset. And I need you to pay attention to that. And S, which is S, by the way, is a side distance. Okay, it is a side distance. Here we are talking about the SSD, the stopping side distance. The SSD is not the passing side distance. SSD. So if you look to the solution that I gave, I solve it both ways. This is a problem here. It's a very good problem, as I told you this. So it is the center line of the inside lane, okay, is not in the reference. In this case, the reference is going to be, okay, assume the position of the driver's eye, A and or C, and of corresponding, okay, object. So 4 feet from the center line, so it's not 6 feet. Okay, and he give you the coefficient of friction, okay, and he give you the perception reaction time, which is A. So I calculated, yes, you need to check only one direction, my friend, but I did it both ways, okay, using the equation and using the standard equation, which is, it depends on the coefficient of friction. Please go over this. Here it is. Use the general equation, and this is the general equation, which is V square over F plus or minus G, and the G, okay. If you like to use the stopping side distance from the tables directly, no problem, but whatever is convenient for you. So I will be glad to scan this problem and send it again, but this is, okay, so the inside lane, okay, is going to be the controlling one, because this is the one that's closer to, okay, to the object that we are trying to set it back far away from the line of sight of the driver, in order to come to a complete stop in case if there is a car or an object on the other okay, side of the curve, like that. Here it is. I'm trying to draw as much as I can. So we take R to the center line of the inside lane. Okay, so I need you to be aware of that, unless he gave you something different, and I will be glad to send the problem, look at it again. Okay, so I need you to be aware of that. So this is the first question that you sent, and let me move to the second question. So this is the first question. Try to answer as many questions as I can, and and as I told you, that you can use the general equation with the coefficient of friction and the deceleration rate, which is A, which is which is 11.2 feet per second square. Look to the problem and let me know, because I still have one more meeting. We are going to meet with you next Saturday also from, okay. Mazin, can you repeat the page number of the figure if we have this book? If you have the book, yes. Sorry, my friend, I was, okay. If you have my book, okay, this is a transportation book. I believe, Mazen, you sent me one equation and you told me that the answer is B instead of A, or something like that. I reprinted, Mazen, and I will look at it. Yes, every problem. So if you send me a question and for some reason I did not address it, please let me know. I don't mean to ignore anybody, or I never intentionally ignore anybody, but probably slip on my busy schedule. And you are very welcome. Even you can ask me today the question if you still remember the question, to correct if there is any typo. But I believe you are right, if I'm not mistaken, but I need to look at it. The page number is six. It is 296, 295, page 295 of my book, page 295, textbook. It's a very good problem 4-24, and the previous page is wait a second, I did okay, 290, 293, 294, 295. Did I say 295? That's correct, 295, because for some reason this here has no page number. I don't know why. 295, and the following, yeah, the following 296, 297. I don't know. This page is missing for some reason. I'm sorry for that. But this is the problem on page 295 of the textbook. But I highly recommend you, my friend, to look at the figure. I have it in my book. Here it is, the one I was telling you about, which is just, we copied verbatim from there. Okay. But I always prefer to go and look. Here it is. This is the original document, or the original book that you are going to get access to during the exam. And this is the HSO in metric and in English, okay, or US customer unit, okay, the HSO offset from all these things. We talked about it, but I needed to emphasize again one more time that the R, okay, is the radius measured to the center line of the inside lane, unless, like the problem I have in my book, the driver's eye is not at the center line of the inside lane. Okay, makes sense? I needed to look. This is a very good problem, and I solved, by the way, 2 or 3 problems related to this, and also in the practice. If you look to the problems number 22, 4-22, and 4-23, and I showed you also how to use the graph, the nomograph. Sorry, not nomograph, the graphs, or the figures, or the charts, much better word, charts, design charts. Okay, and the charts also are given in the same book. Here it is. These are the charts, that the one I use. This is figure 3-14. Okay, and this is on page 3-116 of the geometric design of highways and the street. Okay, and if you look to the second figure, which is the SI figure 3-14, okay, the continued figure, this is, they still call it 314, by the way. It is on page 3-, and these 2 figures are also reproduced, which is also, I gave you the page number and the figure number, and we used it, by the way. We use the English, I believe, or the US customer. Be careful. This is the HSO. Okay, this is US, United States, not United States. US customers, that's called United States Customary System of Units, and this is R to the center line of the inside lane. I wrote it here in my book. Okay, and this y-axis here, which is R, is not a regular scale. It is a log scale. Log. Do you see? It is 10, 100, 1000, and I went over this during the class, and I hope, and okay, and also I talked about that portion of these curves provided, which it has a stopping side distance, and V is a speed, and the S here is a stopping side distance. So the S is the stopping side distance, okay? And there is a dotted portion of the curve, and there is a solid portion of the curve. And this is, okay, they limit the super elevation rate, as you know, to 12%. We have no super beyond 12%. So the Emax, if you remember, we talked about the Emax, it is limited to 12, okay, percent, okay, and we have some limits if the road is icy or snowing or something like that, has snow and ice. We talked about all these things, over elevation, and I'll remind you. So they make the line to be solid up to the maximum, which is the minimum radius when E is equal 12, which is the maximum super elevation. So you'll find that the portion of these curves, okay, solid line, and after that start to be a dotted line where the super elevation is going to be exceeding 12 and is not allowed by the code. So that's why they make it as a dotted line like this. I need you to be aware of that, okay? So I hope this is the answer to your question, my friend, and I hope that all of you, but please go over this problem, because this is, I would say this is a straightforward problem, easy problem. The only thing that sometimes they trick us, okay, is, and we need to know how to solve the equation in reverse, okay, because I gave you the equation in my book. If you look to my book, page 291, you will find that the table that I just showed to you on page 3-15 of the NCEES, no, of the AASHTO. I provided an equation and I give it a number, which is a 426. This is just to solve for S. They might give you the, and I have some problem. They give you the HSO and they give you the R, and is asking you what is the stopping side distance, the SSD. You can very easy, you can find this from this very easily, okay? So try to do your best if they ask you to calculate the stopping side distance based on given HSO. So in reverse, instead of giving you the information to get the stopping side distance and calculate the horizontal side offset, no, he told you that the horizontal side offset is so and so, and what is the minimum stopping side distance required per the given information. So basically, I provided you with the equation, but since you cannot take the book with me, I try to make sure how to get this from there. It's very easy calculation, but yeah, we need to know how to get the inverse cosine -1, okay, cosine inverse cosine, how to do that using your calculator. I need you to master your calculator, how to do that. Here it is. So I need, this is the reason that I included this equation, just to pay attention, just in case. I don't know what they're going to ask. I wish that I know, but I'm just guessing, and I'm doing all my best, okay? So let us go to the second equation very quick so we can cover as much as we can. And how do we solve for the ISD on major street intersection, a V major? It will be very difficult. I wish that if you send this question to me, my friend, I know your exam is coming very soon, and I wish that in order to read the question, and hopefully I'm reading it okay, please type it and send it to me, like exactly like your friend did. I know you did some questions. I don't know if this is one of the questions that you sent me before. If you send me the question right now, no, I will not be able to. First of all, I need to read it to absorb it, because I don't like to give an answer for a question that how to solve for ISD on major street on a T intersection with the V major. So and there is nothing given except the vehicle on the minor street which has a stop sign. I really appreciate, okay, to send it to me, but let me just and draw a picture, okay, okay. Right now, if I understand your question correctly, and forgive me, that is a T intersection, and this is a minor street, and this is a major street, okay, and there is a stop sign along the minor street, Okay, as we covered, okay, in B1 and B2, these are the B1, okay, and B2 and B3. The corner side distance or the intersection side distance. Let me zoom out a little bit, at least I can cover the camera, so forgive me for that. So, and I don't know how many lanes here, okay, I don't know. Do we have a median or not? And there is a stop line here, the stop line. This is a stop line. And there is a vehicle here. I need to know what vehicle is that. Is a passenger car or SU car, okay, single unit truck, okay. And this vehicle here that come to a complete stop, there are more than option that it can do. It can turn left from here, which is a B1. This is a case B1. I'll show it to you right now. This is turning left. This is okay. Turn left. Left. Okay. Okay. So right now, turning left, as you know, the intersection side distance, the ISD, or sometimes they call it corner side distance. Sometimes they mean the same thing, my friend. It is equal 1.47. We know 1.4 is VG. Okay, forgive me. It is the TG, the time gap, TG times V major. So the V major must be given to me. V major. Okay. So based on my understanding for the question you just posed, my friend. So in this case, this is one scenario. It says turning left. Okay. So in this case, I need to get the time gap. The time gap, it depends on what type of vehicle, is a passenger car or single unit car, and how many lanes is going to cross. We cover all these things, by the way, and we solve many questions. We solve many questions related to this. I hope that, okay, this is one scenario. The other scenario is that the car, it could be turning right, and this is a B2. Okay. Okay, the B2 is turning right, and I will bring the diagram in just a minute. B3 is not applicable in this case. B3 is going through, but since this is the T intersection, so there is nothing. So this is, and I will bring the diagram to make sure that I still remember B1, B2, B3. Sometimes I mix them, but to the best of my recollection, and forgive me, sometimes I forget, but let us. So this is a concept, my friend. This is a B1, and this was given. Let me just bring it, and I will look to your question. Maybe you would like to add more information to me, but I really appreciate if you can send it to me. Okay, at least we can. So for the intersection side distance, for the corner side distance, let me just bring it, and after that, correct me. Okay, this is a chapter 6 of my book, which is called Intersection Geometry. And if you look to the B cases, here it is. Okay, so if you look to these 3 cases, I'm looking to my book first, and after that, I will show it you in the geometry. So it is a B1. It is a turn left from. Okay, here it is. So the car is. This is a diagram that to illustrate the case of B1, the vehicle on the minor street has to come to a complete stop and is turning left. So I have 2 triangles, okay, the green one and this one here, and the B2 is turning right, and the B3, which I told you, is not in the case because you have a T intersection. That means that we cannot go through. In this case, the case number B3 is not applicable. And this is the equation that they came up with, which is this is the time gap, the T sub G, passenger car, single unit truck, combination truck, with all the adjustment for the additional lane or the grade, effect of the grade. And after that, we solve. Here are the, this is the equation, by the way, 1.47 V major T sub G. This is equation 9-1. Equation 9-1. And after that, I talked about all these problems and we'll solve it. So please go over these problems and and after that they have only one table. By the way, they provide you with only one table for the passenger car, which is a B1, but the other tables are mine. So this table, yes, table 9-7, okay, on page 9-46, yes, this is the table they provided. The rest for the single unit truck and for the combination of trucks are not really given. I just, and after that I have additional problem, and we spend a lot of time and a lot of problems were solved during the class. All what you need to do is to make sure that you understand the concept, and let me know if you are still missing something from the concept or you still need additional explanation. I will be glad to do that. And the problem in the NCEES, which they gave it also the first time, they include this type of problem, okay, in the new, okay, let me see. I think they used to have one. Here it is. Yeah, this we solve this problem together. Problem 45. Okay, so right now we have the following figure. Okay, a single unit truck, so SU, because the T sub G, it depends on the type of the truck. It's passenger or SU or a combination. Okay, on the minor road, which is a stop sign. Here is a stop sign. Okay. Okay, and this is SU theory. Theory is means that it's 30 feet. Okay, the truck is making left into a major road. So this is a major road. Okay, and the dimension of the travel lane, median width, position, all these things are given. The minimum value, okay, of the D, okay, which is the length of the such triangle, because right now this car, okay, we need to make sure that this side triangle here is clear. Okay, so this vehicle here, the SU is making a left turn. Where it will turn from here to here, to this lane. It will not go to the other lanes. So right now the equation that we use, which is the intersection side distance, the ISD, or the corner side distance, the 1.47, okay, V major times T sub G, based on only one lane to be crossed, and based on a grade of less than, here it is, the grade is less than 3%. So that's good. So here that means that no adjustment for grade. He's nice for grade because the grade is less than 3%. So right now, but we need to consider how many lanes is going to cross this guy. Okay, so right now he's going to cross 1, 2, 3, and the median. The median, he gave you the median width to be 22 feet. You have to increase that. You have to convert the median width into a lane, and we'll solve problems also to see what's the equivalent number of lanes in order to adjust, because all this will affect the T sub G. T sub G, they have table, and the table has a fine print under it, as we discussed in the class, and you have to take care of these. I know fine print is really, okay, here it is. And I explain all these things, and this is the time gap for the B1, for example, for, okay, multi-lane roads and median, and for minor roads approach grade, and the grade, as I told you, that 3%, because all these things based on 3%, but here it is 3% or less. So all this has been discussed. Please let me know if you are missing the concept or you are missing the, okay, because we need to understand the concept. It doesn't matter. So right now I need to count how many lanes will be crossed in addition to, he's supposed to cross only one lane. Okay, so the one lane is this one here. So this is gone. So I have 1, 2. So I have 2 extra lanes that this vehicle has to cross. Okay, the width and the median, which is 22. So I have 12 feet, a plus 12 feet, a plus, which is 1 lane, a plus 1 lane, a plus 22 feet divided by 12. I will convert. So this will be the number of the additional lanes, because every additional lane this truck will cross, we have to add the extra time that it will take, and we add it to the basic time, this time gap, T sub G, okay, this is the basic, this is the basic. or this is the basic. Okay, after that you have to adjust it for the number of lanes, and even he said that the median, for example, he said median width should be converted to, so, and we apply 0.57, 0.5 second, 0.57. For example, if it's 18-foot median, it's equivalent to 1.5. So he took 1.5 times this. All these things already we talked about it. Please let me know if this is what you meant by the question or not, and I will be glad to help you. But send me, okay, something like that, drawing or something like that. This is straightforward and easy problem. He should give you enough information based on your question. You are telling me that he did not give you, I really don't know. He should give you enough information to solve the problem. Otherwise it will be an incomplete question from my point of view, because I cannot solve a problem if you don't give me enough information. It will be unfair for me to answer the question. Okay, so please go ahead. Okay, so I please, okay, I believe the question. Again, case A, we covered the case A. And the problem, let me just make, I know I have a lot of questions here. Mechanistic empirical, page 100, R value. Can you please explain the difference between the equation in the NCEES handbook and the ASH2? I know the empirical equations, okay, for the R value. Yes, I will be glad to do that. Okay, the 1500 and all this is. I know the empirical equations. Sometimes they don't agree, and unfortunately, let me just complete the question about the intersection side distance. Okay, case A, since you mentioned the case A, okay, case A, because you told me that there is a stub on the minor load. Stub on the minor load is not a case A, if I understood your question correctly. So if you are talking about the case A, it is intersection, okay, 4-leg intersection like this, okay, and it has no control at all. No control on either road. This is road A, this is road A, and this is the road B, whatever the name they gave you. Okay, so here we have the case A, it no control at all, no control on both roads. This is what they, okay, consider, which is a case number, a case A, or case number A, let me put it that way, which is this. Here it is, case A, okay, no control intersections, okay, and the case A is given immediately before the one I was telling you about in chapter okay 3, let me go to chapter 9, so chapter 9. Okay, so in chapter 9, let us go to chapter 9, and at least you can read more and look at it, and I will be glad to set a special session for you, because your exam is coming very soon, if I remember correctly. Okay, and this is true also for all of you. I will be glad to set up a session, but send me the questions. Okay, intersections, chapter 9. This is the original document. Okay, and if we go to the intersection side distance, is started on page 9-35, and the case A, which is, here it is, case A, according to the book, here it is, intersections with no control at all. So this is on page, by the way, page 9-39, page 9-39. Okay, I need you to, and you notice that, and try to do your best. I know too many references, 9 design standards, plus the ASH2 book is not an easy task to remember which chapter. I agree with you, and that's why try to practice. And every problem you practice, either from my books or from other sources, ask yourself, the famous statement that I mentioned many times, W7 or W6, I don't know. Okay, they have the G7, the most economical or most powerful economics countries in the world. They call it the G7 or G9, whatever they call G right now. But here I call it, okay, W7, which book, which reference, which page, which chart. So let's go to case A. Case A has a problem. Has a difficulty, has a challenge. Let me put it that way. That the challenge is the equations are not given, which is a similar triangles. They gave you, this is a case A. Here it is. This is the case A. This is the table given on page 9-41. I hope the book with you, 9-41. So this is the case A. Case A, where we have no control at all. And this is the length of the site triangle. No, here it is, no traffic control at all, no stop sign, no yield, no signal for sure. And they developed this table based on what? This table, and there is another table on the back. Okay, this table is the adjustment for the grade, which is the adjustment factor for intersection side distance based on approach grade. And they use the 3 plus or minus as a reference or as a datum where the adjustment factor is 1. This is the original table also on page 9-42, so not 900. Okay, the problem, as I told you, or the challenge, that this table, which is in front of you here, which is the same table I was referring to, is based on this. So based on this, okay, what they are saying there is a car coming in this direction. There is a vehicle coming this way, and there is a vehicle coming this way. And this is the driver here, and this is the driver here. This is the driver along the road B, okay? And this is the driver. So this is the line of sight. Each driver is looking to the other driver, because our objective is to prevent these two vehicles to intersect here, which is, this is a conflict point or the crash point. So what they did, they took this triangle outside. This triangle has been taken outside. Okay, based on the given distances. Because if we do have an object here, a tree or a building, we need to make sure that this building or this object here will not block the line of sight. And we use this triangle in order to, which is this triangle here. Let me show it to you in my book, because it's not given in the NCEES, or the AASHTO again. This is a triangle, the green one, which is basically, okay, sorry, no, this triangle here, which I took it outside. Here it is. It is the same triangle, by the way. Here it is. This is a vehicle, and this is a vehicle here. So my drawing, I will be glad to send a copy of this. That is not okay. And we need to know how to do side triangles. So this is a vehicle 1 or vehicle A, and this vehicle B, and this is the point of the conflict here, where they are going to crash. They are going to hit each other here, which is a conflict point. Okay, they call it conflict point. Here it is. We need to know how to do this. And this is the object, which is this distance here. So I took this triangle, okay, which we need to remember the similar triangle approach. Similar triangles. Here it is. I explain it in my book. It is, okay, this distance over this distance as this distance over this distance. This is all what I needed to remember. And he should give you enough information, my friend, to, so basically the triangle that we took outside, this is the driver number A, driver number B, okay, and here is the building. So I'm saying that this distance over this distance, which I call it x1 and x2. So x1 over x2 as, let me get different color, forgive me, okay, as this distance here, y1 over y2. This is just to show you the concept, because whatever this is the equation, I call it equation 6-1 in my book. After here it is, this is the equation here, but I translate this I use letters A, B, C, D, and so I call it here x1 and x2 and y1 and y2, just to make it simple a little bit. After that, we need to translate these distances based on dimensions given to you. It must be the distance A must be given, the D sub A and D. After that, we are going to solve. And I said, this is not in AASHTO. Here it is. If you go back to the recording, you will find that I wrote it and I spelled it out. And I said that please, because if you are not able to generate this equation, you cannot use this table. You cannot. And this is the challenge that I have. So if you are telling me, my friend, again, this is a question that our friend just asked, that he believes that this is a case A, that's fine. I have no problem with that. Just write it down or draw a sketch and send it to me. Handwritten, and you don't have to type anything. And any question, any question that you would like to send it to me, just handwritten, okay, and scan it and send it to my email info. Don't send it to my cell phone. I prefer email. At least I can print it, and instead of sending my phone, I have to connect it to my printer. And info at passpa.com. Like our friend, the one who did the one I was reading the question, okay, to you guys. Here it is. Oh, sorry, I flip it upside down. Sorry, I use the back of this, my friend. Okay, no problem. Please send it to me. I will go to Mazen. He told me that there is a mechanistic empirical, okay, for the pavement, the AASHTO book, and he's telling me compare it with the AASHTO with the NCAAS. Okay, so sorry, here it is. This is the mechanistic, okay, empirical pavement design guide, and you are referring to page 100, if I remember correctly, my friend. Page 100. You said that. Okay. Number 6, initial practice test. Okay. Why cannot we use the equation in the NCAAS handbook? Okay. So you are referring to question of the okay. Let me just get my okay. So you are referring to a problem 65. Okay, let's look to 65. Okay, 65. Okay, this figure is taken from a document that prepared as a project, and is asking, okay, so the DCB, okay, the dynamic cone penetrometer, always this on the exam, by the way. This question, by the way, I needed to, I talked about the DCB, how it's, okay, I needed to know what is the use of it, the use of the DCB, okay, the dynamic cone penetrometer. I can show you. This is in chapter 9 of my book. I can show you where it is. I talked a lot about it. Okay, so the in-place strength, okay, of a silty sand subgrade was given. Okay, and so the DCB index, okay, 20 millimeter, okay, per blow, okay, given the relationship given in the graph, the resistant R of the soil is, so it's taken R, which is the resistant value, the R, okay. So this is one equation he gave it to you, okay, and this is another equation he gave it to you, and this is the equation that's given to you. I believe there was there was an errata for this, if I'm not mistaken. I don't know if I have access to the errata right now, but I believe there was an errata. Look to the errata, my friend, errata of this NCEES. Okay, so since this is the SM and CH and CL, these are the soil type, as you know, by the Unified Soil Classification System, USCS. Okay, he gave you equations, okay, and this is the M sub R, which is the resilience modulus, okay. Whatever empirical equations he gave you on a graph like this, or a figure like this, a relationship between this and the CPR, California bearing ratio, and the DCB, how many millimeter per blow, I will limit myself to these equations, and I hope that his solution based on that. Okay, and because you are saying that, why we don't use the equation given, okay, on another location, unless these equations are not sufficient to answer the question. This is, in this case, I will look to the other empirical formulas. So you are saying that, okay, we use, okay, okay, why cannot we use the equation in the NCEES handbook 3-119 to get the value? When I tried, I got about, okay, 26 for the R value. Can you please explain the difference between so and so and so? Okay, so, and mechanistic on page 100. So let's go to mechanistic page 100 first, at least to see what is your okay, mechanistic 100. Okay, the 114. Forgive me, just okay. So 106, and we are getting close, my friend. This is a 100, which I believe this table, I have it, by the way. I have it in my, okay, so in my book, if I'm not mistaken. Okay, so this is, okay, model use, okay, relating matrix index, okay, for the properties of M sub R, the M sub R, which is the resilience modulus. Okay, so the CPR, the R value, okay, and you are telling me that the ASH2 or the NCEES, they have a 3-19 chapter 3, which is a geotechnical, which is the pavement, and you are talking about page number. I will look at it as I told you, Mazen, and if I'm not able to get, okay, on page 3, section 3-19. Handbook 319, I don't know, 31, which is this one here. This is section 319, unless you mean page 319. No, it cannot be 319. Okay, so I will print it. Okay, and you are talking about, let me see the equation. If the, okay, so this is, okay, if you are referring to this table here, this is on page 3, no, 225, if this is what you meant. Okay, the R value and all these empirical formulas. Okay, so this is a granular base, sub base. If you are talking about these equations that's given here, okay, 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 so in summary, because I need to come back to you about this. Okay, so in summary, as far as these set of equations or this set of equations, theoretically speaking, they're supposed to matching, but as I told you, we have too many empirical equations. Sometimes they don't match. So my question to you, and we can go over the problem and look to the errata if I remember correctly. Okay, did you use the equation that they provided here or not, or whatever the relationship they gave it to you? The number of equations they gave you, or the number of relationships given here, were sufficient to solve the problem or not? If this is their intent, which I believe their intent from that, because why you provide me the equation? Okay, and okay, so I believe they should provide you with enough equations in order to solve this problem. This is my best guess right now, my friend, that you should use these given information and this given relationship to solve the problem. This is why you give it to me, why you give me all these relationships, okay, and you ask me to go and look for another relationship, especially identify the soil type, okay, for each relationship. So this is what my assumption. I don't know if you go to the solution of 65 after they look to the errata. Okay, so problem 65, okay, and mechanistic empirical pavement and page, okay, 100, the CPR and M sub R and 18. So unfortunately he's referring to the table, the one I was telling you about, the table I was referring to, which I don't know why they give you all these equations if this intention is to go to this table here, which is a table on page, okay, table 9-8, which is this table I was talking about, which I think I included in my book, if I'm not mistaken, because this table is important. Let me look at it and come back to you and see, but I need to get the errata first, because I believe there is a typo somewhere. Please look at it and let me know, but I will look at it and come back to you. And I remember that you also sent another question. If you remember the question right now, since we tried to make to answer, as there was one question you told me that and I will look to see, you are telling me why you cannot use these on page 225, okay, in order to, theoretically speaking, if they came from the same source, this empirical format, they're supposed to be the same, supposed to give you the same answer. But let me, okay, again, answering any question on the spot immediately like that, I need to do the calculations and I do the stuff, yeah, because it is an ethical issue for me. I cannot really answer unless okay, so please, okay, send it to me, and also remind me with the question that you sent before about one of the answers that you suspect it is not correct. Okay, I appreciate that. Let's go to another question, the written question, and I prefer if you can send it to me like this, like our friend here. Okay, if spiral curves are used, is a typical spiral transition at both ends, the beginning and the end? The answer is yes. Okay, normally we provide, okay, the transition curves, one at the beginning and one at the end, as okay indicated, okay, in my book again, and the book is showing the spiral curves, and the spiral curves, okay, are shown in horizontal design in chapter the horizontal design. This is way back, the horizontal design, which here it is. Okay, so if you look to the figure 4.8 of my book, you will find that that the transition curves are provided, which I colored here as a blue, okay, one at each end, and this is tangent to spiral, and this is spiral to curve is C, and this point here is curve to spiral CS. I needed to be familiar with this. And finally, the ST, which is a spiral to tangent. So those are the four abbreviations that I needed to be familiar with, or remember them, or try to, okay, remember as much as you can. So the tangent to spiral, spiral to curve, curve, okay, curve to spiral, and finally spiral to tangent. Those are the four. So we provide, yes, a transition curve at the beginning and the end of each one. Okay. If yes, do the spiral transition curve on each side circular curve. Okay, having the same, yeah, that's correct. Because right now, because this radius here, this R, okay, this R, there is R here, this is the radius of the circular curve, but the spiral has a radius, and the radius is changing from infinity all the way up to here, where the radius of the spiral and the radius of the circular curve are equal. And the same story, the radius here is the radius for the circular curve, and after that the radius start to be increased from R here all the way up to here, which is infinity. And this is they came up with the P, with this distance P minimum and P maximum. And I believe one of the question some of you asked me, by the way, here it is, the length of the spiral, okay, transition. Okay, this is the equation, and there is another way. Yeah, we take, by the way, here it is. I believe this is a question. It's one of you. So the minimum length is based on the P minimum, and the P minimum, by the way, is 0.66 feet. Okay, and we take the larger of these two. I believe the question one of you asked me, yes, this is the equations given in the from the Ashto book, chapter 3, 327 and the 328. We take the larger of these two. You're supposed to check both of them, and the maximum length based on the P max, and the P max is equal to 3.33 feet. So the P max, as I explained it here, we have something called P min and P max. We use this to determine the minimum length of the spiral curve, and we use this to determine the maximum length permitted by the spiral curve. And here are the equations based on, and they put it the P max, and the P max is 3.33 feet, or the 1 meter, and the P min is a 0.66 or the 0.2 meters, as all of you know. Okay, so this is a question, my friend. So this question already, okay, they are symmetrical. Yes, normally we make, okay, the two spiral curves, okay, at the beginning and at the end are equal, because much easier to lay out it in the field, unless they have some constraints on the other end. One end does have it has constraints compared to the other end, okay, or we have some constraints. But it for the accuracy and for the easy to lay out in the field, normally we make it, okay, these two curves are essentially the same. Okay, vertical curve, and I will answer this is the last question here. Okay, the table 16, I don't know, I will do my best if I the run out test. Okay, the vertical curve is the high point on the crest or sag vertex always on the steep of the flatter side. Can you go over when we will find always low and high? Okay, again, this is okay. Let me just do this very quick. One of you is asking me a question. I will answer you, my friend. Just let me do my best here. Okay, for the vertical design in chapter 5 of the NCEES, all of us, we know the two equations, which is a curve equation, and the tangent equation. Equation or elevation, sometimes they call it elevation, tangent elevation, and the curve elevation. I call it elevation equation, which is a y, the elevation y at any distance x is equal the y of the b, sorry, let me use bvc plus g1x plus ax squared, or it could be y of the bvc plus g1x plus the a is equal g2 minus g1 divided by 2l. times x square. These equations are available for you. Okay, you don't have to memorize it, or if you memorize, that's good news. In order to get the low and the high point, we take the first derivative, dy by dx, and we equate it to 0, because we know in calculus that whenever we have a curve, a tangent to a high point and a tangent to a low point, this slope here is 0, and this slope here is 0. We know that from calculus. So I took the first derivative. The first derivative will give you 0 with this constant, a plus g1, a plus the g2 minus g1, and the 2 will cancel with the 2l, and I still have 1x here. And this is the distance x that we are going to use. So I have g1 plus g2 minus g1 divided by l times x. Okay, so I need to solve for x. So x, this is the slope. Okay, and they call it x max or x min. Okay, x max or x min, and x max or x min in this case, either one of them, and could be used, is a negative g1 divided by g2 minus g1 divided by l, or negative g1l over g2 minus g1, or we can make this as positive as g1l over g1 minus g2. Let me just verify this equation. I don't like to assume that the equation is correct. Okay, and this is in chapter 5, and after that I'm showing you, just in case if you don't have time to go and look to the equation, you can just take the first derivative and equate it to 0 and solve for the x as I just did, and I hope that I did it right. And here it is, which is the x max or x min. Here it is. This is on page, by the way, page 279, which is g1l over g1 minus g2, and I believe this is what I got, g1l over g1 minus g2. So this is exactly the same equation that I got. Okay, so this is to get the high and low point. Okay, the high and low point. So for whatever curve is, either seg or crest, as you said, okay, and okay, and this is a BVI, point of vertical intersection, or simply the vertex, and this is a BVC, and this is a BVT. I hope that I'm using the same notations, because I don't like, BVC and BVT, because I don't like to confuse you. And this is the vertical curve. Okay. And this is a G1, and this is G2, and from here to here is L, and from here to here is L over 2, and this is L over 2, because we are talking about symmetrical vertical curves. Okay, so the low and high points. Okay, number one, I needed to remember that this, the low point, okay, at BVI, or the vertex F, G1 is equal negative G2. So the low point, assuming this is a low point, and that I'm referring to, this is true. This low point will be above this or at the L/2 only and only if the G1 and the G2 equal magnitude opposite sign. So if I have here negative 4% and this is a plus 4%, so I needed to make sure that, or I needed to know, let me put that way, that you understand that, or you remember that the low point is here automatically. And we can derive this. This is, okay, case number 1. Case number 2. So if it is the low point, low or high, obviously, or high, because we're talking about the same equation, because this equation, the one I was talking about, this equation is applicable to all vertical curves, symmetrical or unsymmetrical, both positive, both negative, all just only one equation for all types of vertical curves, except the unsymmetrical vertical curves. We have to create, or we have to generate another 2 grades in order to use this equation. And I covered one problem only in a case of unsymmetrical. I don't expect the unsymmetrical to be there, but just in case, and go over the problem in my books and let me know if you are having a question. Okay, the case number 2, which is related to the question, but I just made this introduction here. If the grades are different, let us, for example, this one here, okay, this is a G1, which is assumed negative 4%, okay, and this here is a plus 3%, okay. Let's make it steeper, a plus 5%, because it looks like a steeper. Okay, and we have the vertical curve. Okay, and this is a BVT, and I should mention something. Okay, and this is a solid line like this. Normally I make this is a BVI, and this is the correct shape of the vertical curve. What do I mean by correct shape? As you see, I draw here a point here. This point, it does have a name, and I solve a problem in the class. Okay, they call it mid-chord point. Theoretically speaking, this, we don't have a chord like the circular curves, but they call it also, this is a chord, and this is equal this mid-chord point. And sometimes they ask you what is the elevation of the mid-chord point. The mid-chord elevation of this point is equal this elevation plus this elevation divided by 2. And I solve a problem related to this. Okay. I need you to know for a fact that for symmetrical vertical curves, okay, that this distance is equal this distance here and this distance here. This is why we always say that the vertical curve, it is midway between the mid-chord point and the vertex. This is called vertex, by the way, vertex. So the vertical curve, if you draw it correctly, it lies midway between this point and this point. This way, this vertical from here to here is equal from here to here, and we solve a problem, if you remember, okay, in the NCEES, okay, there was a problem. I believe they still have it, if I'm not mistaken, and I explain this concept over there for you guys, at least to make sure that we are okay, still remember this. Oh, the book is here, the book. Sorry, my books, I have too many books around me. So you can go over this problem one more time. if you would like, okay, which I believe um, uh, for some reason I maybe is no longer here. Okay, because it is related to this directly, my friend. Let me just give me another 22 seconds. If I couldn't find it in 22 seconds, I will quit, and I will assume that that is no longer here. Now here it is. Yeah, a problem number 37 of the NS. An overhead sign is located at the BVI of a crest vertical curve, and the grids are given in order to provide a clearance 16 feet, the minimum elevation of the bottom of the sign. This is exactly what I'm talking about. Okay, so okay, because you can calculate the distance or the elevation based on what I'm just mentioned, that this distance is equal this distance, and this distance is equal this distance. Okay, so right now to go to the question. Okay, I could say that yes, here it is, and I show you the problem, but I needed to understand it. Okay, right now we have one low point and one high point for any given curve. So for this sag vertical curve, we have only one low point. Now the grades are different. This is a grade and this is a grade. This is considered flat grade compared to this is steep grade. The higher the number, the steeper the grade. Okay, so assuming that this L here is equal 800 feet. My question to you, do you expect the low point to be here, like when you go to the eye doctor, position 1, which is on this side, okay, or position 2, whatever the distance? I'm not talking about the distance right now, but I'm talking about it will pass along the 5% grade or along the 4% grade, or on the side of the 5% grade, or on the side. Okay, we can look this very quick, which is x min is equal to G1 is -4 and the L is 8 divided by, I'm using this equation, we just did it. Okay, G1 is -4 and the G2 is -+5. So if we do this simple calculation, this is 32 divided by 9, and obviously this is minus will be plus. So 32 divided by 9. Remember, from here to here, we're talking about this is 4 stations or 400 feet, and this is 400 feet. If you look to to 32, which is, I hope that my math is correct, and make sure that negative G1 times L. Okay, just correct my mistake. By the way, I just made the problem. 32 divided by 9, obviously it is less than 4. Okay, and this gave me 3.5 stations. So I know from here, from the beginning, which I told you, this is my reference. Always we use, all distances are measured from here. This is the reference. Do you remember that? So the lowercase x in the equation, or the uppercase x, which is x max or x min, all of them are measured from here. So right now the x came to be 3.5 stations. So I was talking about position 1 or position 2. So it is on the flat side of the curve. So the x, so the low point is somewhere here, and this is the x min. If I use the same curve, okay, but I will make this one here, this I will keep this -4%, and I will make this is a plus 2%. Okay, and I'm using the same curve length. L is equal 800 feet. So right now I will leave these calculations here. This is related to this. So the X min in this case, just simple calculation to draw the conclusion. And so it is negative G1, which is negative 4 times 8. This is 2 right now. This is a flatter grade. So remember, 4 versus 5. Right now, 4 versus 2. This is a steep grade and this is a flat grade, okay, irrespective to the sign. Okay, so right now divided by G1 is negative 4, negative G2 is a plus 2. So right now this will give me 32, and this divided by 6. What is 32 divided by 6? Obviously it's more than 4. 32 divided by 6, so it is right now it is 5.3. Oh my god. Okay, it is 5.3 stations, if my math is correct. 4 times 2 and 6, 32 divided by 6. Okay, so it is 5.3. So right now, the again is the low point at position 1 or position 2, position 1 here, or position 2 here along this side, As you can see, 5.3 will pass the BVI, which is 4. So I am here. So the conclusion is the low and high points all was located on the side of the low grade or the flat grade, like this 2%, and like this is a 4% irrespective to the sign. I hope this is clear. Go over these numbers one more time and let me know if you agree or disagree with all of the above. Okay, so so I believe I addressed all the questions that you sent to me, except there is one at the bottom here. You sent me the table about the table, okay, 16A, which is the super elevation. The super elevation run rate has different values in my version, okay, maybe okay, updated errata and so on. I noticed that the practice example, so on, no problem. No, I will use here we are talking about the super elevation. This is the chapter 3. If chapter 3 of the NCWTS, chapter 3, if I'm not mistaken. Let us look to this is not the right book. This is chapter 3. I will use the tables that given in the NCWTS, which is the this table here, my friend. Here it is. This table for the L sub R, table 16A. This is the original document. Don't use mine, okay? Don't, if you feel that mine, as far as I know, I review it, and many engineers helping me review it. Maybe, okay, there is something, I will look at it if you tell me that, but I will go to the original document. And if there is a typo here, obviously they are responsible for the typo. So there are, so this is the table 16, 316A, and this is the 316A here, which is, and also they have it in the SI, which they call it 316B. And we use these tables. Let me know how can I help you if you forgot how to use the tables. It is in the recording, but I will be glad to go over this. Okay, so I know you have probably more than what I covered today, or you have more questions than what I covered today. I do my best. Let me grab the last question so I can start, because I'm helping also the FE. The FE start immediately, by the way, so I need to help them also. And for those who are going to take the exam very soon, you are very welcome to send, and I will do all my best to squeeze half an hour, 1 hour, whatever I can squeeze. For sure, I will not hesitate to keep helping you guys. Okay, and if your exam coming very soon, leave room to your friends. Send me, okay, I know there was one of you taking the exam very soon, and the following week, I believe, and another one the following week. I don't remember the name. One of you asked me who was going to take the exam. Just many engineers taking the exam, and I don't remember, so forgive me if I didn't give you the names or the dates, whatever. Let us learn, but let us prepare. The bottom line is, and forgive me for saying this more than once, the bottom line, the 500 hours. This is from my point of view. You need to sit and study and do mistakes, and I'm here to help. But if you did not put the hours and you believe that 1 month before the exam will be sufficient to ace it, no, no, no. Exams are, unfortunately, especially the challenge of the searching through all these PDFs. I know it's not your fault, it's not my fault, and if we take them to court, we will lose. So instead of going to the court, let us study, and I'm here to help. Anything that I need to explore more or dig in, please send it to me, because this will give me. Okay, so let me just conclude this by saying thank you very much for coming, and let me grab the question here from one of you at the end, and if I miss anything, uh, uh, let me grab the question from one from New York. That's correct. That's correct. Always you put it exactly. You put it okay. Always okay. Located where the grade is flat. That's correct. That's completely correct. Okay. This equation is specify to cell. That is my. This is why question 65 could be used. I believe you are mentioning this, Mazen, about the question 65. I will look at it. I will print your question, and I will answer it. No problem. No problem. Okay, just keep working, keep studying, keep doing all your best. Keep. I don't know if you get a chance to solve the problems. I sent it to you or not last time. I send you this practice exam. I don't know if you did it or not. Please do it. It has a very good problem. Very good problems. That I send it with the solution. I don't know if I send it without solution. I would be glad to send it without solution. Let me stop here, and if you don't get the recording, please let me know. Please, okay, do your best, communicate with me, and I will do all my best to help you guys. But never give up, please. Never give up. Let's be optimistic, but don't forget the 500 hours. Okay, I know you are upset with me, but I will keep repeating this. Okay, thank you very much. I wish the best to all of you. Bye bye, everybody.